Hello, Charan. How are you?
Fine, sir.
Right. Okay. Let's wait for a moment and then we'll start. Okay.
Okay, sir.
Is there any other class going on
No, sir.
before just 8?
Sir,
Just before 8, any other class is there?
at 5 to 6, there is a class, sir.
Okay. 5 to 6.
Yes, sir. Max class.
Right. Hello, Lokesh. How are you?
Good evening, sir. Fine, sir.
Right. Okay. Let's just start. Yeah. Manal also joined. Okay.
Hi,
So,
sir.
good evening, everyone. How are you, everyone?
Fine,
Fine,
sir.
sir.
Let's just start now. Okay. Okay. So, last thing we have done it in our previous class was electric field calculation, right? Due to the charge distribution, right? So field due to ring we have calculated at the center and on the axis, isn't it? Next thing we have calculated where it will be maximum and what will be the maximum value and the graph part, okay? And we have also calculated if the point is very close to the center, then how the field will behave, and if the point is very far away from the center, then how the field will behave, right? These two things also here it is. This is for the point very close to the center, and this is for the point very far away from the center. Okay. Next, field due to uniformly charged disk we have calculated. Again, at the center we got it 0. And for axial point, what we got it? Sigma by 2 epsilon naught 1 minus cos theta. Cos theta is nothing but x by under root of r square plus x square. And if it is a large disk, right? If it is a large disk, then what will happen? The field we got it as the sigma by 2 epsilon naught. Then we calculated electric field due to uniformly charged thin wire. Again, we used what? The integration method, and we got two component of field. One was perpendicular to wire component, and other was parallel to the wire component, right? So perpendicular to wire, we got it k lambda by r sine alpha plus sine beta, and parallel component, we got it k lambda by r cos alpha minus cos beta. So then, two, three special cases we have seen. If it is symmetric, then only which component will come? Only the perpendicular component came, है ना? For symmetric case, only the perpendicular component came. Parallel becomes 0, right? For infinite wire, again, only the perpendicular component was there. parallel was 0. And this is the semi-infinite. One point is at finite, another point is what? Other end of the wire is what? At infinity. Okay. Now let's discuss one more field due to circular arc, and then we will discuss the questions. Okay. So the next one we have electric field due to circular arc. Okay, circular arc. But here we are going to calculate where? At the center we are going to calculate. At the arc center we are going to calculate the field. Okay. So let's say there is a circular arc here. Okay. There is a circular arc having uniform distribution of charge. Let's say that charge distribution is something lambda. And this arc is making what? Some angle na here, right? And the radius of the circular arc is r. So now if you calculate the field at the center, can you tell me what will be the direction of field?
Downwards.
Downward, right? So field due to circular arc, whenever we calculate, the field will always come what? Along the line which is the angle bisector. Along which line? Along the line which is drawn through the angle bisector. So it means if the arc has, let's say, I am going to consider the total arc angle as what? 2 theta. So what are these two angle will become? Can I
Theta, comma, theta.
say these two angle will become theta because that blue line is representing, the blue line is representing the angle bisector. So field here will be what? Always along the angle bisector line. And how much it will be? The field is going to be k lambda by r. What are the two angles? Sine theta plus sine. Clear? Please tell me, is this part clear? So if you
Yes,
are
sir.
calculating the electric field due to the circular arc at its center, the field will always come what? Along the angle bisector, and the value of field is going to be how much? K lambda by r sine theta plus sine theta. And what is theta theta? Theta theta is the half angle of the arc. Total angle of the arc what we consider is the 2 theta. So theta and theta is the half of angle. Okay. Chili, can we discuss some example now?
Yes, sir.
Okay, let's discuss some example now. Okay, in this first example, what is given to us? In this example, it is given to us a circular arc is there. Okay, a circular arc is given. Okay, circular arc of radius r is given to us. Okay, and there are two, or let's take it only one infinite section. Okay, let's take it only what? One infinite section. Something like this. This end is extended up to infinity. And the charge distribution on this one is given as plus lambda. And charge distribution on this one is given as minus lambda. Okay. Here the charge distribution is a negative charge minus lambda. Here it is given plus lambda. And radius of the arc is given as what? Radius of this semicircular arc is given as r. So what we have to find out? We have to find out E net at the center of the arc. So please tell me, in this question, can we consider it a combination of a circular arc and a semi-infinite wire? Please tell me, is it the combination of a semicircular wire and a semi-infinite wire? Please tell me.
Yes, sir.
So, due to semicircular wire, we know that how the field will come, isn't it? So that I'm going to write it as the 1. Okay, this semicircular wire, I'm going to write it as the first segment, and this semi-infinite wire as the second segment. So tell me, at center, if I just bifurcate it and try to calculate it one by one, can you tell me how we will calculate the field at the center? Tell me, due to semicircular
Due to
wire, how much the field will come?
it will come inwards 2k lambda by r.
Right, how much it will be? Will it be towards the center? Sorry, will it be towards the wire? Why it is
Yes, sir.
coming
It will
towards wire?
negative charge.
Negative charge, that's it. Very good. So can you tell me what will be the value of this E1? Is it going to be
2k
K
lambda by
lambda by R? What is theta?
pi by
Is the
2, sir.
theta is pi by 2 pi by 2? So can we write it here? Sine pi by 2 plus another sine pi by 2. So what we got it? 2k lambda by R. Is that part? First part is clear? Please tell me. Due to circular arc,
Yes.
we got it now. Now I will go to the second part. So for the second part, if I am doing, please tell me, is this the wire given to us? This is the one end of the wire. And where is the second end of the wire? Second end of the wire is extended up to infinity. And is this the point where I am trying to calculate it? Please tell me, what is the perpendicular distance? Is the perpendicular distance is again equal to R? Check it. Because to calculate the field due to a wire, we need the perpendicular distance, isn't it? So is the perpendicular distance is equal to R?
Yes, sir.
Please tell. So now, due to the second segment, if I calculate the field here, how many component will come? Two component will come or only one?
Two component.
Two components will come, right? Can I say perpendicular component is going to be like this? And is it value is going to be K lambda by R? One angle, this point is making how much angle with one end? One
One
end,
end
it is on
90
the
degrees,
perpendicular
other
line.
end 0 degree.
Yes, so we can write it here sine 90, other one we can write it as sine 0. So do we get it K lambda by R? What will be the other component? Is the other
Parallel.
component will be like this?
Yes,
Let
sir.
me call it
Anti-parallel.
as the parallel component. And do you understand why it is in this direction? Because net field will try to be in this direction. Look at that.
Yes, sir.
This is the direction of what? The net field due to the semi-infinite wire. So that's why perpendicular component will be in that direction. So how much it will come? That parallel component, how much it will come? K lambda by R cos alpha, let me put it as the cos 0, and another beta, let me put it as the 990. So what we got it again? K lambda by R. So that means at the center, how many fields are there? Please tell me. At the center point, due to arc, one component came, E1. Due to semi-infinite wire, is the two component is coming. One perpendicular component, one parallel component. And what next we are going to do it? We are going to add these three component what? Vectorially, isn't it? So net field at center, if I want to calculate, let's draw it vectorially, okay? Please tell me, is this the E1? Please
Yes,
check.
sir.
Is this the E1 2k lambda by R?
Yes, sir.
Is this the perpendicular component k lambda by R?
Yes, sir.
And is this the parallel component again k lambda by R? So if someone
Yes.
asks you in the question that this is your I cap direction and this is your j cap direction, so what is the net field you will tell in the vector form? Are you going to write net field in the vector form k lambda by R minus I cap plus 2k lambda by R and k lambda by R, 3k lambda by R plus j cap. So this is the field in which form? This is the field in the vector form. And if they just ask you, what is the magnitude? So am I going to get the magnitude as k lambda by r common under root of 1 square plus 3 square? That means root 10. Someone can also ask you, what is the direction of net field? Right? Can I say the direction of net field will be like this due
Yes,
to
sir.
complete
Theta.
arrangement? Can we can we find out what is going to be this angle? Let's call it phi. Am I getting the tan
Tan
phi
inverse of
equal to y component by x component? So is it coming 3 by 1? Just check it. Please tell me. So whichever
yes,
they
sir.
will ask
3.
you, whichever way they will ask the question, we can answer it. But what we have learned in the question is it's a combination of what? Combination of circular arc and the combination of what? The straight segment. So that's why we have calculated what will be field due to circular arc and what will be field due to straight segment. Please tell all of you understood this question,
Yes, sir.
Yes, sir.
right? Let's discuss the next example now. Okay, let's discuss 2, 3 more example on that. Now, in the next example, what is given to us? In this example given, a circle is given to us, okay? A circle is given to us, and this circle has charge distribution like this. Here the charge is plus lambda, okay? Here the charge is minus lambda. Here the charge is again given as, let's take it plus 2 lambda. And here the charge is what? Minus 4 lambda. Can we find what is the net field at the center? Please tell me.
Yes, sir.
How do you find it? Tell me.
Sir, we can cancel out 1 lambda from 2 lambda because it's opposite. And from minus lambda also we can
Yes.
cancel it. So we'll get plus lambda and
Yeah,
minus 3
that is
lambda.
very good. That is also, you can do it, right? All of you got it, what he's saying? See, same diagram, I am going to draw it. See, what he is saying, that is the one way to solve it. There is longer method also, okay? But what he said is little bit shortcut method. What he said, sir, whatever the plus lambda will create the field, isn't it plus 2 lambda and plus lambda will create field in the opposite direction of each other? Please tell me. Field due to this plus lambda and plus 2 lambda will be in the opposite direction of each other. So effect of plus lambda is gone. Effect of this plus lambda is cancel out by this one, है ना? And this one will behave like what? Instead of plus lambda, I should take it what? Plus 2 lambda, I should take it as the plus lambda only. Do you understand? Please tell me. I will take
Yes,
the
sir.
longer method also and I will explain to you. But please tell me first, do you understand this one?
Yes,
Whatever
sir.
the field plus lambda in the first quadrant will create, in the third quadrant, 2 lambda will create exactly opposite of that one. Right? So that means net field of first and third quadrant will look like what? Only the plus lambda, which is in the third quadrant, right? So that's why plus lambda of first quadrant, you can remove it. Now look at this one. Can I again do same thing here also? Minus lambda, minus 4 lambda. Please tell me. If I eliminate it, what I will get it here? Will I get it after eliminating here minus 3 lambda? Please tell me. Do you understand this one? Now instead of 4 arc, I only have to calculate due to the 2 arcs. Okay, and this is the arc. What is the angle bisector will come? 45 degree, 45 degree, na? Please tell me. Is it the
Yes,
field
sir.
due to the third quadrant?
It will be
Let's call it
away, sir.
E. Is that E is going to be K lambda by R? Sine 45 plus sine 45? Please tell me, what is the angle? Half angle. Half angle made by the arc. Sine 45 plus
1 by root 2 plus 1 by root
sine 45. 1 by root 2 plus 1 by root 2. 2 by root 2. The root 2 we got it right. Now tell me, due to this one, due to 3 lambda, what direction it will come?
towards the
Will it
wire.
come towards, right? Let's call this as E dash. So what is the E dash we have? Is the E dash is K 3 lambda by R. Again sine 45 sine 45. Can I write it? Root 2. And sine 45 plus sine 45. Now you can draw it in this diagram form, isn't it? This vector is how much? K lambda by R root 2. And how much is this vector? 3k
3 root
lambda by R root 2. And can you say that these two angles are 45 also? Tell me, this angle is 45 also. And this angle is also what? 45 degree. Now, can I write it in the I cap J cap form now? If this is my I cap and this is my J cap, can I take component and write it in the I cap J cap form? So what is this component will come? K lambda by R or root 2 K lambda by R cos 45. Cos 45 1 by root 2. How much this will come? K lambda by R root 2 sine 45 will come. Same way, if I take the component of the other one, what I am getting? Is it coming 3k lambda by R root 2 cos 45? And this one will come 3k lambda by R root 2 sine 45 will come. If you simplify this diagram further, are you getting root 2 getting cancelled out from everywhere? Just check it. So 3 plus 1 is that we have 4k lambda by R, and here 3 minus 1. So is it 2k lambda by R? So can you tell me what is the net field at that point coming to us where they ask, is it 4k lambda by R with I cap and 2k lambda by R with minus J cap?
Yes, sir.
Please tell all of you, Charan, Manal, Lokesh,
Yes,
Talvi.
sir.
Yes, sir.
So always try to break it into what? The standard segment. Okay, standard segments are what? The line, ring. Okay, if we can break it into a standard segment, we can always get the answer. Okay, now one more question. Tell me here in this example what I'm going to give you. We have calculated field at which point? We have calculated field if this is the wire, right? Along the perpendicular direction we have calculated the field. Now in this question what I'm going to give you, there is a wire. I'm going to choose a point which is along the wire itself given to us. Understand? Due to the wire, we are going to calculate the field at a point, and the point is along the wire itself. Clear? Where is the point? The point is wire itself, and that is the point where we are going to calculate the electric field. Okay, so this is the length of the wire given as something L, and the point is lying somewhere here. This is the point P, and let's take that point P is what distance? Something A distance, and this has a uniform charge distribution of lambda. This has uniform charge distribution of lambda. You have to tell what is the field at point P. Find field at point P one more time. What you will do? We have not written any formula like that, isn't it? So please tell me, should we start with the taking element and finding first field due to a small element? And once we can calculate what is the field due to a small element, then what will happen? We will
Integrate
integrate it to get the field due to net field due to the wire, isn't it?
limits A to A plus.
Yeah. So what we should do it here? Please tell. So at this point, I want to calculate it. Can I do one thing? Let me consider a small element at a distance x, and this small element is going to have what length? The small element is going to have what? The dx length. So what will be dq? Dq means charge on the element. Is the charge on the element is going to be linear charge density into dx? The first thing we got it, right? This. Next, what is the field created by this small element? This is a small element, na? So I can consider them as a point charge. So this small element will create how much field? Let's call it a dE field. How much is that going to be? K dq by r square. R means distance square. What is the distance? X square. And what will be the field at this point due to a small element? Is that going to be away? Please tell me. Field at this point due to the small element is going to be which direction? Away from the charge. है ना? अब you see, is it all these points are going to create the field away, away, away only? So all these small field are in the same direction. So if I want to calculate the net field, I should add all those small electric field. And if it is a continuous summation, what we can do? Can we write it? It's going to be the integration of d. So let's put the value of dk. What is dq? Lambda dx divided by x square. And please tell me what is the limit of x? So is the x is going to start at this point, and is the x is going to finish at this point? So isn't it my limit of integration is x is going to start from a, and is it going to finish at a plus l? Please tell. That is going to give us the net field. Okay. So what is the net field? Tell me, can we do this integration? K is a constant, lambda is a constant. Dx by x square integration. Is it minus 1 by x? Please tell.
Yes,
Please tell me dx by x square integration, how much it will come? Minus 1 by x will come. Now let's put the limit a to a plus l. So k lambda minus outside. Upper limit if I put it to 1 by a plus l minus lower limit if we put it to a will come. So what we have k lambda, let's send the minus inside. So 1 by a minus 1 by a plus l we can write it. We can do further simplification if you want. K lambda, if you take LCM it will become a into a plus l, a plus l minus a. So a and a got cancelled out. What we have? K lambda l by a into a plus l. That is the net field at that point. Please tell me now, will you able to calculate distribution charge? If it is a line charge, if it is a ring, if it is a circular arc, please tell me. Can we calculate now?
yes, sir.
Yes, sir.
Please tell clear. So that's why this ring, see, most important is what? Ring, line charge, and the circular arc. These three are having the maximum number of questions, okay? And maximum different type of questions you will get it in these cases, okay? Understood the electric field calculation? So see, in the electric field, what we have learned? How to calculate electric field due to point charge first. Then what we did? Then the second thing we did, if there are numerous charges, hai na, there are many number of charges, what we should do? We should calculate field due to indivisible charges, and then vectorially we should add the field because field is a vector quantity. And after that, if it is a distribution of charge, then we cannot apply kq by r square. So what we should do? We should first choose the element in the body and calculate the field due to element. And after that, what we will do? After that, with the help of integration, we will calculate the net field created by a distributed charged body. Okay. So now next we are going to discuss is, before electric flux discussion, we should know what is electric field lines. Okay, please tell, is that clear? What is the electric field lines? Please tell, clear everyone?
Yes, sir.
Right. So what is electric field lines? Can you tell me what is the electric field lines? Hello? Hello?
Sir,
Yeah, tell me, what is electric field lines?
sir, the lines generated by a charged particle.
Lines
Electric field lines.
generated by a charged particle. Anything else? Anyone else want to add something? Please tell me. Please tell, try it, na?
Sir, the lines generated by a charged particle that represent its magnitude and type of particle.
Okay. See, electric field lines, what we said, the charge lines generated. If you are saying like that, can I say that if a charged particle is there, so it means some lines will be coming out from the charged particle?
Yes, sir. And in negative charge, it will be towards itself.
Is there really lines are coming out of the charged particle? Or it is just the representation of the electric field?
Imaginary line.
Imaginary lines, right? There is no such lines comes out from a charged particle. So why do we call it electric field lines? So see, till now, if I ask you what is the field at a point, so what you will say? Sir, give me the charged particle magnitude and give me its nature. Tell me the distance where you want to calculate. If I give you all these data, what you will do? You will tell me the exact magnitude and direction of the field created at a point, isn't it? Someone wanted, no, I don't want to know exact value. I just need a rough idea about what is going to be the field at a point. Or I just want to have a rough estimation of that. If this is one point, this is another point, where the field is stronger. I don't need the value. I just need what? The comparison. I just need, tell me if this is the field, if this type of field lines here and this type of field lines here, just tell me which is the positive charge, which is the negative charge. Okay, so electric field lines is what? It is a graphical way to represent the electric field produced due to a charged particle. Is that clear? What is the electric field lines? It is a graphical way to represent the electric field. Okay, not the analytical or mathematical way. Understood? So what is this? It is graphical way. Okay, what is that? It is graphical way to represent the electric field around a charged particle. Electric field around the space created by what? Created by a charged particle. Okay, so it doesn't give us any calculation. Matlab, if I give you the electric field lines, it will not tell me exact value, but yes, we can do the comparison. Okay, so it is graphical way to represent the electric field, created by a charged particle. Okay, so we will have some rough idea. Clear? So now let's see what are the things we have about the electric field lines. Okay, so electric field lines means what? If I have a positive charge particle, so from a positive charge particle, see that the field lines will be what? Coming away. It doesn't mean these lines are coming out of the charged particle. Okay, these lines are coming out of the charged particle. It is just represents that what direction the field is, what direction the field is created by a positive charge particle. Okay, so first thing what we understand, the direction of arrow, does it tell us the direction of field created by the charge particle? Please tell.
Yes, sir.
Direction of arrow represents what? The direction of field created by the charge particle. And due to a negative charge, what direction the field lines will be? The negative charge create the field towards it, isn't it? So that's why for the negative charge particle, if I draw the field lines, how it will drawn? It will be drawn towards the charge particle. Okay, that is the first thing. So it means if I know if a field lines are coming out of a charge particle, can I directly understand that must be a positive charge particle? If field lines are terminating at a charge particle, can I say that that charge particle must be a negative charge particle? So by just looking at the direction of electric field lines, I can answer that the what? Direction of the direction, with the help of direction, I can tell that what is the nature of the charge particle. Is that understood? First thing. Second thing. Second thing is what? That here, whenever we draw the field lines, okay, if I take two imaginary area, if I take two imaginary area of equal, two equal imaginary area, and if I see the area through which more number of field lines passes, then can I say that that point will have stronger field compared to what? The other point? How? Tell me. Let's see. What does it mean by this thing? Let's say a positive charge particle is there. Okay. This is how the field lines will come now. Please tell me, everyone. Is it how the field lines will be coming?
Yes, sir.
What did I just say here? This is how the field lines will come. Okay. Something like this. What did I say? I am going to imagine two area, and I'm going to take the area of what? Same magnitude. One, acha, let's say without field lines. I'm going to give you 2 points, okay? Let me call this is the point 1, and let me call this is the point 2. Can you tell me which point the field is stronger, 1 or 2? It's a point charge, right? It is a point charge, and I want to know that which point has stronger field. Point number 1 or point number 2? Can you answer it?
2, sir.
Which has more stronger field, 1 or 2?
Stronger field, 1.
Please tell me, which
1,
one will
sir.
have a
1.
stronger field? 1. Mathematically, we know that, right? Because point 1 is near to the charge particle, and field due to a charge particle is kq by r square. So as I go away from the charge particle, the field strength decreases, isn't it? As we go away from the charge particle, what happens? The field strength decreases. So we know that the field at 1 is stronger than the field at 2. Now the same thing I want to understand of how much stronger and how much less. So for that I need exact value of charge, exact distance from the charge particle, isn't it? Then I can exactly tell you how much it is. 1 point it is 10 Newton per coulomb, 1 point it is 8 Newton per coulomb. Like that I will answer you. But I don't want to know exact difference. I just want to know that which is stronger and which is less. Please tell me what I will do. See that at point 1 and point 2, what I consider? I consider equal area. From which area more number of field lines are penetrating through? Look at the diagram and tell
1.
me. From
1, sir.
which area of cross section more number of field lines are penetrating through? See that?
1.
1.
1. So that means the more number of field lines passes through a point, the stronger will be the field. That is another thing we understood from the field lines. What the next thing we understood? That you can also see this statement written like this: relative strength of electric field lines passing through the area of cross section, or you will say density of electric field line passing through a cross section area. The more denser the field lines are through a cross section area, the stronger the field will be at that point. Please tell me, do you understand?
Yes, sir.
Please tell me. Now, the third point about the field lines. So, what is the help of field lines? The field line give me another help of determining which point is having a stronger field and which point has less field. Okay. Third one, let's say I'm going to take like this and like this. How the field lines will look like? Will it start from the positive charge? Will it end at negative charge? Right now? Like that, many field lines will be passing through, and something like this. 1, 2, 3, 6, 3, 9, and 3, 2, 5, 3, 8, 9, 3, 12. Okay. The green color, I'm going to represent it here. See, please tell me. I'm going to hide this thing. I'm going to hide this thing. You will answer me now that what is Q1 and what is Q2? Which is positive charge, which is negative charge, or both are positive, both are negative? Please answer it.
Q1 is
I did
positive,
not.
Q2 is
Very good. How do you understand that Q1 is a positive charge and
Q1 has
Q2 is the
outward
negative charge?
Q1 has its field
Yes.
outwards, whereas Q2
From
has
the
its field.
very good. So Q1 has field away from itself. So we came to know that Q1 is a positive charge and Q2 is field terminating on the charge particle. So Q2 will be negative. That is the first thing we understand. Very good. Now I want to compare Q1 and Q2, which has greater magnitude. मतलब if I say Q1 is 4 coulomb, what is Q2? Is it Q2 minus 5 coulomb or is the Q2 is minus 2 coulomb?
The Q1 is than Q2.
Tell me, how do you know that? That Q1 strength, sorry, Q1 magnitude is greater than Q2 magnitude. Can you answer it by looking at the graph?
Yes, sir. More number of lines.
Yes. Look at the number of field lines emitting and terminating. Number of field lines emitted by Q1 is what? Is it more than the number of field lines terminated on Q2? Number of field lines emitted by Q1 is definitely more than what? Number of field lines terminating on the Q2. So that means Q1 must be of more magnitude charge compared to what? The Q2. Understand? So number of field lines coming from a charge particle, it also represent the strength of the charge particle, magnitude of charge particle. So if I say one charge particle is emitting 20 field lines and other one is emitting 10 field lines, can you just tell me the direct comparison? Can I say the first one is 2 times a stronger charge particle than the other one? मतलब magnitude of first charge is 2 times greater, 2 times than the magnitude of the second charge, because it is emitting exactly 2 times the field lines emitted by the other charge particle. So number of field lines emitted by the charge particle is in proportion of their magnitude of charge. Is in proportion of what? Magnitude of their charge. Understand? See that looking at the field lines, how many important information I have. Looking at the direction of field line, I can determine whether a charged particle is positive or negative charge particle, right? Positive charge particle away from itself, negative charge particle towards it. Second thing, if I want to compare the field between 2 points around a charge particle, I will draw an imaginary area, right? And we'll check it through that same area should be same because we want to do the comparison. We should take the same area at two different points. The area through which more number of field lines passes through. That is the point where the more electric field will be there due to the charge particle. Is that clear? Third point, number of field lines emitted by a charge particle is in proportion of its magnitude of charge. That is the third point, and this example explain everything about the third property. Clear? So third property is the combination of what? 1, 2, like that, isn't it? Now, there are some more properties of the electric field lines, okay? So tell me, what are some of the property? Can we just write it like a highlighted point? Please tell me. Electric field lines are what? It is a continuous curve. Matlab, there won't be any breaking in the pattern. Okay? So next point about the electric field lines are what? Electric field lines are what? Continuous curve. Okay? Next thing. Can two electric field lines intersect? Listen. Is it possible for two field lines to intersect? Is
No,
the
no,
no.
no,
Why not? Because if it intersects at a point, then at that point there are going to be two direction of field possible, na? So at a point in the space, we have a unique magnitude in direction of the field. So that's why electric field lines what can never intersect. Okay. So electric field lines can never intersect. Okay. Next one. When we draw the electric field lines, what happened? If I want to see electric field lines, if it is a straight one, then we will say electric field is uniform in this space. But that may not be always the case. Sometimes the electric field in a space can be variable also. So that's why if we draw tangent to the electric field lines, tangent drawn to the field line represent what? Tangent drawn to the field line represent the direction of electric field at that point. Okay, direction of what? Electric field at that point. Direction of electric field at that point. Is that clear? So if I tell you with the help of example, can I say that I have drawn a field line like this? Okay, this is the field line. So please tell me, what is the direction of electric field here? Should I draw the tangent here? If I want to know field here, should I draw the tangent here? Right? So you see that this is a field line. Can I say this is an example of non-uniform field lines? Please tell me. Can we say this is an
yes, sir.
example of non-uniform field lines? Because you see the direction of field lines are changing. Direction of electric field is changing at a different point in the space. So this is an example of what? Non-uniform electric field. Okay, this point what it will be? I should draw the tangent there, isn't it? Okay, so if you draw the tangent at any point, okay, on the field line, then what will happen? That tangent will represent the direction of electric field at that point. Okay, next, can the electric field line be uniform? It can be non-uniform also. How do we represent uniform electric field lines? See, look at that. I am trying to make it as good as possible. Yeah. Please tell me, this is an example of uniform electric field or non-uniform electric field?
Uniform electric.
uniform electric field. Why? Because if you look at the direction, is the direction is always in the same direction? And you see the spacing between them. Spacing is also same. So that means what? This is electric field lines represented, or this electric field lines is representing uniform magnitude and always in the same direction. Okay, so this is called uniform electric field representation, or this field lines represent what? Uniform electric field. Matlab, what is constant? It means magnitude is constant and direction both constant. Magnitude and direction both constant, right? Because you want a vector to be uniform, na? A vector can be only uniform if its magnitude remains unchanged and if its direction remains what? Unchanged. Can you tell me what is this representing? Is it representing uniform or non-uniform field? The
Non-uniform.
second case represent uniform or non-uniform field?
Non-uniform.
Non-uniform electric field. Why it has become non-uniform? Due to magnitude or due to direction? Please tell me why it become non-uniform? Because its magnitude, is changing, है ना? But what about the direction? Direction remains same. Understood? See, na, direction is always horizontal, na? Always along the x-axis. And the third case. This is the third case. Can you tell me what is this field? Please tell me what is this field representing? This is also non-uniform field. And in this case, can I say that here the magnitude is also changing continuously at a different point and direction both are changing. So can I say in this case magnitude and direction both changing? Okay, magnitude and direction both are changing in this example. Okay, to understand how do you identify, sometime they will give you in a question, identify the case of what? Uniform or non-uniform field. Okay, if they are asking uniform field, check it, magnitude and direction both should not change.
Yes.
Non-uniform field can be of two way, by only changing the magnitude, by only changing the direction, or changing both of them. Next property of the electric field lines are what? Electric field lines are conservative in nature, okay? Or better to say that electric field is a conservative field, okay? So electric field lines are conservative in nature, are conservative field in nature. So that's why what happened? That's why they never form what? The closed loop. So you will never find an electric field lines which is going to form the closed loop. So if you find at some point that there is an electric field lines given which is forming a closed loop, so that is not a electric field line. That is not the correct representation of the electric field lines. So electric field lines are conservative in nature, so they never form. Okay, so there never forms a closed loop. Okay, never forms a what? The closed loop. Understood this point? And one last point, how the electric field lines will look at the conductor. If it is a conductor given to you, okay, let's say if it is a conductor given to us, conductor, metallic conductor, or just written as what? The conductor. So how the field lines will be for a conductor? If it is a conductor, the field lines on a conductor will be what? Perpendicular to the surface of conductor. And again, what will happen here? It will come out and like this. Like this. Okay, so electric field lines on a conductor surface. Is it a correct diagram? Just see that I made already a mistake. Please tell me, is it the correct free body, correct field lines? Please tell me, is the field line 1, is it a correct field lines? Is the first line represent the correct electric field lines? Second one, is it representing the correct field? And third one, is the third one is a correct one? Out of 1, 2, 3, which is the correct one? Please tell me, out of this 1, 2, 3, which is the correct one? Is the first one is correct? See, external field is there. At the near to the conductor, it is perpendicular, it has become. Again perpendicular coming out, and again it is following its own nature. So first one is the correct field line. Second one is also what? Correct. Why? Because of this. This is the point itself. No? This is the point itself. So that means second one is also what? Correct one. Why the third one is incorrect? Can you tell me? Because in the third case, I did not put them as perpendicular to the conductor. Because of that, this third one is the incorrect. Understand? This third one is what? Incorrect representation of the electric field lines. First one is the correct one. Second one is the correct one. Is that clear? So electric field lines near a conductor is always what? Always perpendicular to the surface of conductor. So if it is a conductor surface is kept in a electric field lines will terminate on the conductor and again terminates on the conductor perpendicularly and again emanates from the conductor perpendicularly. Understood? Please tell. So this
Yes,
dotted
sir.
line is just for making you understand. It's not like that the field line inside is representing the dotted line. It is just for making you understand that is it a perpendicular drawn or not. Okay, so let me remove this one. Okay, otherwise you will be thinking there is a field inside also. We don't have electric field inside a conductor. We will learn about it when we will learn the properties of the conductor. So please tell what we discussed. Understood? So once we understand the electric field, so electric field lines passing through a surface area, what is that called as? That is called the electric flux. So tomorrow morning we are going to discuss about first about the electric flux calculation using using the dot product method, and E dot dA we will use it, and then we will discuss about the flux calculation using the Gauss law and its application. So please tell, understood what we discussed till now?
Yes, sir.
Yes, sir.
Right. All of you got it? So
Yes, sir.
tomorrow class will be from 9 in the morning, right?
Yes, sir.
Okay.
9 to 10.
So let's, yeah, 9 to 10. Okay. So let's meet it tomorrow. Okay. And we'll continue
Of
with the
course.
electric flux and Gauss law.
Okay, sir.
Right then, everyone, take care.
Bye, sir.
Okay. I will share the notes with you.
Okay, sir. Thank you.
Thank you so much. Take care.